Let us come back and solve this 2011 paper. Very interesting questions given here. They've clubbed 2 to 3 concepts together. Right, let's see. What do they ask us? They've given you certain complexes like this. And they've asked us to name the complex. Okay, nomenclature is included. Stereochemistry, that is your geometric, whether it shows geometrical or optical isomers. Then they've asked you magnetic behavior, that is from the VBT. So for the magnetic behavior and hybridization, I've done a video in which is numbered under video number 30, 31 and 32. Please watch that. You will understand how to calculate magnetic behavior. That is with the formula mu s. Let us write that. Mu s is equal to root n into n plus 2. This is the formula. So I've explained that. Please go to that. Let's start. First I have to name the compound. How to name? Start from here. This is potassium, because there's no place. I'm writing in 2 lines. Potassium. Done. Then come back to the ligand. Hexacyano. Negative ligand, isn't it? So manganate. This is manganese. So we call it as manganate. Now, next important thing, you have to write the charge. Here cyano is -6, -1 into 6. Potassium is +1 into 4. The difference of this is 2, isn't it? So Roman number 2 complex. Done. Let's come back and name this. We're going to start from here with the ligand. Pentamine. Now this is chloride, that means the negative ligand. Negative ligand, we take out E and replace it with O. So this becomes chlorido. Then come back to cobalt. Now cobalt configuration. Okay, let us put this first in the Roman numbers and come back and name this. This is chloride. Now let us write the oxidation state. Now this is a neutral ligand, the charge is 0. This is -1, this is -2. Together it becomes 3. Next let us name this. This is potassium tetracyano, negative ligand, so O, nickelate. Right, let us calculate the charge. Cyano is -1 into 4, -4. Potassium is +2, +1 into 2, +2. So the difference of this is 2. So nickelate 2 complex. This is your name. Now let's come back to the next concept, stereochemistry. Very important. So whenever you are speaking about stereochemistry, you have to speak in terms of geometrical isomers and you have to speak in terms of optical activity or optical isomerism. So what is the requirement for geometrical isomerism? That is your cis and trans. Important. The metal atom should have 2 different groups, like means 2 different ligands, like AA, BB. This can show cis and trans isomers. For something to show an optical activity, it should have all 4 different groups, A, B, C, D. Yeah, then it's going to rotate the plane polarized. Let us come back and see. Here in this case, do we have inside the coordination sphere, do we have 2 different groups? No, isn't it? So geometrical isomerism not possible. Let's come back to optical. Here I said all the 4 groups should be different. So all are similar. So optical isomerism not possible. Done. Let's come back and see this. In this complex, you have 2 different groups. Okay, 2 different groups. What can I say? Okay, 2 different groups, as well as there's one more ligand also outside. So you have to be very careful. In this particular case, geometrical isomerism, if I have to say, this ligand 5 are similar. 5 amino groups, 5 plus 1, 6. So 5 are similar. So I can't take geometrical isomerism, not possible. But optical activity, yes, it is possible. Why? These ligand and this is a different ligand, isn't it? Yeah, when I have 2, this and this, this is 1 amino and you have a different ligand here. So optical activity, yes, possible. Let's come back and see. In this particular case, geometrical isomerism, all 4 are similar. So geometrical isomerism not possible. For this particular thing, optical activity A, B, C, D. There is no A, B, C, D here. For chiral carbon, optical activity not possible. Done. When I have to come back to the magnetic behavior, I said please watch this video. You will have an idea how to calculate using this formula. But as of now, I am writing it. This is paramagnetic in nature. This is also para. This is dia. I'm just simply writing. Please watch the video. Para means after hybridization, you will have unpaired electrons. Here also it's the same. Dia means all will be paired. So this is how you're going to answer the question.